How reliable are floating point comparisons? Floating point numbers are the black art of computer programming. One reason why this is so is that there is no optimal way to represent an arbitrary number. The IEEE, Institute of Electrical and Electronics Engineers, has developed a standard for representing floating point numbers, but you cannot guarantee that every machine you will use confirm this standard. Even if your machine does not confirm the standard, there are deeper issues. It can be shown mathematically that there are an infinite number of real numbers between any two numbers. For computer to distinguish between two numbers, the bits that represent them must differ. To represent an infinite number of different bit patterns would take an infinite number of bits, because the computer must represent a large range of numbers in a small number of bits, usually 32 bits or 64 bits. It has to make approximate representation of most numbers, because floating point numbers are so tricky to deal with. It's a generally bad practice to compare a floating point number for equality with anything. Inequalities are much safer. For instance, in this example, we can add hash include stdio.h. Just look at this program. Constant float first equal to 0.0, assume 0.0, constant float last equals to 7.0, constant float small equals to 0.0. so float f for the crucial part here is for f equals to first, f not equal to last, and f less than last plus 1.0, f plus small, printf f now. However, rounding errors and small differences in representation of the variable small might cause f to be never be equal to last, isn't it? It might go from being just under it to being just over it. The loop would go past the last value. The inequality f less than last plus 1.0 has been added to prevent the program from running on for a very long time if this happens. If you run this program, the value printed for f is 71 or more. This is what has happened. A safer way to write this loop is to simply use the inequality f less than last to test for the loop ending. For example, I can modify the program just like this. Look at this. So I can have a count for f equal to first, f less than last, f plus equals to small. Instead of that, you could even pre-compute the number of times the loop should be executed and use an integer to count iterations of the loop. By just getting the count is very simple. Count equal to last minus first divided by small. So float f, and for f equals to first, count minus, that is decrement the counter. If it is greater than 0, f plus, and the f plus equals to small. So this is how we have to take safety precautions, and this is how reliability of floating point is associated with most of the compilers. Thank you.